Hello students, today we are going to look at section 10.2, Simplifying Radicals. And if you think the room looks a little different, it's because it is. We are not at school right now recording a video, I'm actually doing this at my house. So, welcome to my home. 10.2, Simplifying Radicals. It's important before we get started that you understand what the perfect squares are. So I need you to list these, but not just list them, memorize them. You need to know that the perfect squares are 4, because 2 times 2 is 4. And then we have 9, and then we have 16, and 25, and 36, and 49. And then after 49 we have 64, and then 81, and 100. And then we could keep going, but those are the ones that you absolutely need to know. After 100, it's important to know all the ones up to 25, but we'll just stop right there for right now for today's purposes. So the perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, and 100. And it's important to know those because you're going to need to be able to pull out factors in just a second. And these are the factors that you're going to pull out because these are perfect squares and I can find the square root of them. Okay? So now that we have that information, let's look at a couple of examples. So I'm going to say, first of all, I need to simplify the square root of 80. So I need to think to myself, is there a perfect square factor of 80? Well, one of these, which one of the largest numbers will go into 80? And you're probably thinking to yourself, 16. You're exactly right. So I can say that 80 equals the square root of 16 times 5. Because 16 times 5 equals 80. Well, I can further simplify it to make it the square root of 16 times the square root of 5. So now I know that the square root of 80 equals the same thing as the square root of 16 times the square root of 5. That's just the property rule of radicals. So I know that the square root of 16 is 4. And there's no perfect square root of the square root of 5, so I just leave it as the square root of 5. So the simplification of the square root of 80 is 4 times the square root of 5. So what I'm doing is I'm trying to take a square root that's a pretty big number typically and simplifying it so that I can pull out the perfect squares, make that a whole number, and then have what's still under the radical sign left over. So 4 times the square root of 5 is the same thing as the square root of 80. So the next two examples we're going to do are the square root of 54 and 3 times the square root of 32. So I want to start with the square root of 54. So I have to think in my head, are there any factors of 54 that are a perfect square? And you're probably thinking in your head, 9 times 6. So we know that the square root of 54 is the same thing as the square root of 9 times 6. Because 9 times 6 is 54. So I can take it a little farther, the square root of 9 times the square root of 6. And I know the square root of 9 is 3, so 3 times the square root of 6 is the square root of 54 in simplest form. Well, let's go over here and we've got 3 times the square root of 32. Can I simplify that any farther? So I first of all just look at what's under the radical 32. Are there any perfect square factors of 32? And you're probably thinking in your head, 4 times 8. But don't stop there because 4 is not the highest perfect square factor. 16 is actually the perfect square factor. So we have 3 times the square root of 16 times 2. Because the square root of 32 is 16 times 2. Okay? So if I've got 3 times the square root of 16, that can also be 3 times the square root of 16 times the square root of 2. Well, we know that the square root of 16 is 4, so 3 times 4 is 12 times the square root of 2. So 3 times the square root of 32 is simplified to 12 times the square root of 2. The next little part of this section that we're going to look at is multiplying square roots. So let's say I have the square root of 2 times the square root of 14. Well, we know from what we just did is I can take 2 and multiply by 14 and I get the square root of 28. Because as long as they're both under the radical, I can just multiply them and they stay under the radical. So now I've got the square root of 28, and I have to think to myself, are there any perfect square factors of 28 that I could pull out of this problem? And actually there are, because the square root of 28 is actually the same thing as the square root of 4 times 7. I'm going to take a little shortcut now. We know that the square root of 4 times square root of 4 is 2, so 2 times square root of 7. I'm just eliminating that step of rewriting them separately. You don't really have to do that in the learning process, but I'm just showing you the square root of 4 is 2, so it goes outside the radical, and the square root of 7 is still underneath the radical. Well, let's look at another one. Let's say we have something like the square root of 3 times the square root of 15. Okay? So we have the square root of 3 times the square root of 15. I know that 3 times 15 is 45, so we've got the square root of 45. Now, are there any perfect square factors of 45? Yes, there are. They are the square root of 9 times 5. And we know that the square root of 9 is 3, so the simplified form is 3 times the square root of 5. And notice that I don't have to put a multiplication sign between those two, because that radical sign simply acts as a grouping symbol, and we know that when we have a number next to a grouping symbol, that's multiplication. So the square root of 3 times the square root of 15 is simplified to 3 times the square root of 5. The last part of 10.2 for today that we're going to look at is simplifying a square root with variables. So let's talk about a little bit about finding the square root of a variable. Okay? The first thing I need to look at is x squared. What are the two factors of x squared that multiply together to equal x squared? That would be x times x. Okay? So the square root of x squared is x, sort of. Now let's say we take the square root of 9. The square root of 9 could be 3 or negative 3. But since if it's 3 or negative 3 and both of those could be x, 3 does not equal negative 3, so I can't just leave it as x. Because x could be 3 or x could be negative 3, but I can't say they equal each other. So in this case, I have to put the absolute value of x. When the exponent under the radical is even and the exponent outside of the radical is odd, then I have to use the absolute value. I'll say that again. When the exponent under the radical is even and the exponent outside the radical is odd, because this is a 1, 1's an odd number, then I have to use the absolute value sign. So let's look at x to the third. Now with x to the third, I need to see what is the perfect square factor of x to the third, and that would be x squared. Because remember, when we multiply same base, we add the exponents. So x to the third is the same thing as x squared times x. So the square root of x squared we know is x times the square root of x. Now you're thinking to yourself, why didn't you use the absolute value? Because the exponent underneath the radical is an odd number, so this rule doesn't apply. Okay? I simplified it here, but still the original was an odd number, so this does not need an absolute value. So let's look at the square root of x to the fourth. X to the fourth, what two factors can multiply to x to the fourth? It would be x squared times x squared. So I know that the square root of x to the fourth is just x squared. Now, do I need to use absolute value? No, because this is an even number, this is an even number, I don't need to use the absolute value. I only use the absolute value when I've got an even number under the radical and an odd number outside the radical. So let's look at x to the fifth. What are the two factors of x to the fifth that can multiply to, one of which is a perfect square? That would be the square root of x to the fourth times x. Because remember, what I'm looking for, or maybe you don't remember, I'm just telling you, what I'm looking for is an even numbered exponent. Because then I can take the square root of that even numbered exponent. So x to the fourth times x to the first is x to the fifth, because I add the exponents. So now, can I find the square root of x to the fourth? Yes, that's x squared times the square root of x. What I like to do is that when I use it, I cross it off, just so I don't get confused. I can't find the square root of x, so it just goes down to the square root of x. So the simplified form of x to the fifth is x squared times the square root of x. So now we're going to look at simplifying some square roots that have numbers and variables. Okay? So I have the square root of 90x to the third, y to the fourth, z to the fifth. So I need to find some perfect square factors that I can factor, find the square root of, and then see what's left under the radical sign. So give me some factors of 90, one of which is a perfect square factor. And you're right, it's 9 times 10. So I'm going to rewrite this as the square root of 9 times 10. Now can I find the square root of x to the third? No, I have to break that down into x squared times x. And then y to the fourth I can leave because it has an even exponent. And then z to the fifth I need to break down into z to the fourth times z. So now let's find the perfect squares of what we can, and we'll leave what we can't. So the square root of 9 is 3, so I'm going to cross that off. I can't do anything with the square root of 10 right now, but I can do something with the square root of x squared, and that just makes x. Cross it off. Can't do anything with that x because it's just x to the first power. I can't find the square root of anything. So then I have y to the fourth, and I know that the square root is y to the second, so I cross that off. And then I've got z to the fourth, it's the square root of z to the second, and then z is left. So I've taken out all those perfect squares that I can, and what's left is now the square root of 10xz. So 90x to the third, y to the fourth, z to the fifth simplified is 3x y squared z squared times the square root of 10xz. So let's look over here, 56. X to the fourth, y to the 10th, z to the 7th. Now, are there any perfect square factors of 56? Yes, there are. This is kind of a stretch of one. 56 is the same as 4 times 14. And we know that 4 is a perfect square. So I'm going to do 4 times 14. X to the fourth I can keep because it's an even exponent. Y to the 10th I can keep because it's an even exponent. And then I have z to the 7th. What adds up to 7? Exactly. Z to the 6th times z. So now let's find the square roots. The square root of 4 is 2. Cross it out. I can't change the 14 because there's no perfect square factor of 14. But I can find the square root of x to the fourth, and that's x squared. And I can find the square root of y to the 10th, which is y to the fifth. Ding, 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 ding. Even exponent under the radical. Sorry, we got to start at our original. Even exponent under the radical, odd exponent outside. I have to use the absolute value symbol. And now, cross it off because I've used it. So z to the 6th would be z to the 3rd. Remember, we're starting with the original. This is odd, so it doesn't matter about this absolute value. And then I cross it off. What's left under the radical? 14z. So this would be times the square root of 14z. So the simplified version of 56x to the fourth, y to the 10th, z to the 7th is 2x squared, absolute value of y to the 5th, z to the 3rd, times the square root of 14z. So here are your 3 practice problems. The first one, simplify the square root of 24. The second one, simplify the square root of 5 times the square root of 10. Remember, you have to multiply the 5 and the 10 first, and then simplify after you get that. And then the last one is simplify the square root of 63 m to the 3rd, p r to the 5th. Once you have those done, take a picture of it and submit that picture via Edmodo. Something that you guys need to just really understand is you will not get a 100 unless you submit this picture via Edmodo. I'm not checking notes anymore. You have to submit it or you will receive a 0. Please don't go to all this work to take notes and watch the video and then not submit it, because then you receive a 0. Submit the picture. You're using your iPad. It's right there. Please take a moment, submit the picture right now.